right. The following Zoom session is being recorded and will appear later today on my YouTube channel, Math with Mayo. There are two different classes that may be observing this session. Therefore, when you participate in the Zoom meeting, if you do not wish for your picture or your name to be made public, please leave the video off and use an alias name. If you have questions during the meeting but do not wish to speak, email me at bmayo@ybcc.edu and I'll respond as soon as I can. All right, so today we're going to pick up where we left off, which was section 5.6. Before we start, any questions on anything we did yesterday that you're got questions about? Okay, well, we'll go ahead then and go on to section 5.6, which is multiplying polynomials. Okay, let's take a look here. Let's say we've got something like this, basically a monomial. Negative 2a cubed times 11a squared. So that's negative 2 times 11, negative 22. A cubed times a squared is a to the 5th power. Any questions about how that works? All right, here's another example. Negative 5x cubed y to the 6th times 2x squared y squared. So that would be negative 10 x to the 5th y to the 8th. Then let's say we've got 3a times a plus 2. So now we're taking a monomial times a binomial. Distributing, we get 3a squared plus 6a. Any questions there? All right. How about negative 6s times s squared minus 3. Distributing, we get negative 6s cubed plus 18s. And then let's see. How about this one? We've got a monomial. Times a polynomial. 3x squared plus z squared plus xz minus 1. So this becomes negative 12 x to the 4th z minus 4x squared z cubed minus 4x cubed z squared plus 4x squared z. And there are no like terms that we can combine, so that's as far as we can go. All right, now let's take a look at where we have a binomial times a binomial. So this is where we get that idea of FOIL. We take the first times the first, y squared. Then we do the outer ones, y times 5 is plus 5y. The inner ones, 3 times y is 3y. And the last ones, 3 times 5 is 15. Then combining like terms, we get y squared plus 8y plus 15. Any questions there? And then another example, n plus 8 times n minus 10. N times n is n squared. N times minus 10 is minus 10n. 8 times n is 8n, and 8 times minus 10 is minus 80. Combining like terms, n squared minus 2n minus 80. All right. Or how about one with fractions? 8t minus 1/2 times 4t minus 5/2. 8t times 4t is 32t squared. 8t times minus 5/2, we'll write plus 8t times minus 5/2, and we'll come back to that in a minute. And then minus 1/2 times 4t, and then minus 1/2 times minus 5/2. Okay, so we get 32t squared Here, the 8 and the 2 reduced to a 4 over 1. So we've got minus 20t. Here, the 4 and the 2 reduced to 2 over 1. So minus 2t. And here, nothing reduces, but we get what? Plus 5/4. Combining like terms, 32t squared minus 22t plus 5/4. Any questions there? All right, let's say we've got a situation, hang on here, where did my mouse go? Move that over a little bit, where we've got a binomial times a trinomial. So here we've got x times x squared is x cubed. X times minus 2x is minus 2x squared. X times 3 is 3x. Then 2 times x squared is 2x squared. 2 times minus 2x is minus 4x. And 2 times 3 is plus 6. Combining like terms, x cubed, the minus 2x squared and the 2x squared cancel each other out. Plus 3x minus 4x would be minus 1x and then plus 6. So we get that. Okay. What if we have something like this? 4x times 2x plus 1 times x minus 2. We can multiply the first two factors together and then distribute that, or the second two factors together and then go from there. Let's do it in order from left to right. So first of all, we'll do these two. This becomes 8x squared plus 4x. We're then going to take the results times the x minus 2. We get 8x cubed minus 16x squared plus 4x squared minus 8x, which is 8x cubed minus 12x squared minus 8x. Okay. Well, let's go on and take a look at some special products. So this is section 5.7. We have something like this. We have what's called a conjugate pair. We're multiplying the sum of two numbers times the difference of the same two numbers in the same order. When we do that, when we FOIL it together, we get two middle terms that cancel each other out. So we end up getting what we refer to as the difference of two squares, because we have the difference of two squares. Let's say we've got something like this, m plus 4/5 times m minus 4/5. Again, we've got that conjugate pair situation. M times m is m squared. M times minus 4/5 is minus 4/5 m. 4/5 times m is 4/5 m. And 4/5 times minus 4/5 is minus 16/25. Combining like terms, the middle two terms cancel out, and we're left with m squared minus 16/25. Okay, now, let's say we've got something like this, y plus 7 squared. We need to be very careful. This is not equal to y squared plus 7 squared. What we have to do is recognize that we have an exponent of 2 and a base of y plus 7. So we have two factors of y plus 7, which we then FOIL together, y squared plus 7y plus 7y plus 49. Notice here, this is not the difference of two squares. We don't have a conjugate pair. We have two identical factors. So the middle terms do not cancel out. And we get what we refer to as a perfect square trinomial. That is a trinomial with two identical factors. Let's say we've got something like this. M minus 5, but the quantity is cubed. So now we have 3 identical factors of m minus 5. We can only multiply together 2 of them at once. So we'll do the first 2 first. This is m squared minus 5m minus 5m plus 25, which further combining, we get m squared minus 10m plus 25. Then we take that result and distribute it through the last factor of m minus 5. So we get m cubed minus 5m squared minus 10m squared plus 50m plus 25m minus 125. Combining like terms, m cubed minus 15m squared plus 75m minus 125. And we get that ginormous thing. And let's see here. Okay. Now we need to be careful if we have addition and subtraction and multiplication all mixed together. Let's say we've got this situation. 5a minus 1, the quantity squared, minus the quantity a minus 8 times a plus 8. Okay. Now, order of operations, we do exponents, then multiplication, then subtraction. Okay. So we're going to take the 5a minus 1, the quantity squared, oops, expand that. If I would just slow down. So here we get 25a squared minus 5a minus 5a plus 1, which is 25a squared minus 10a plus 1, minus a squared plus 8a minus 8a minus 64, a squared minus 64. Oh, but wait a minute, we need to be careful. We're subtracting this entire product. We're subtracting this entire product. We're subtracting this entire product. So we need to do that. Okay. And then distribute 25a squared minus 10a plus 1 minus a squared minus times minus plus 64. So we got to be very careful there. This is 24a squared minus 10a plus 65. Okay. Let's see here. Let's go on to section 5.8, which was dividing polynomials. So starting out with, if we have a monomial divided by a monomial, a to the 12th divided by a to the 8th. If you're dividing 2 powers with the same base, you have the base to the top exponent minus the bottom exponent. So you'd get a to the 4th power. Let's say we had 22b to the 9th over 6b to the 6th. 22 over 6 reduces to 11 over 3. B to the 9th over b to the 6th is b to the 9 minus 6, which is, excuse me, b cubed. So we get 11b cubed over 3. Or you could write it as 11 thirds b cubed, but be careful that you don't write it like that. That b cubed has to either be in the numerator or sort of straight out from the fraction bar, implying that it's still in the numerator. All right, now let's say we have a polynomial divided by a monomial. Then we take each term of the numerator and divide it by the term in the denominator. And then go back and one by one reduce each fraction. 8 over 4 is 2 over 1, so 2x plus 1. Or if we have something like this, 16b to the 10th plus 4b to the 6th minus 20b to the 4th all over 4b squared. So a polynomial divided by a monomial, we take each term in the numerator and divide it by the term in the denominator, and then go back and reduce each fraction one at a time. 16 over 4 is 4 over 1. B to the 10th over b squared is b to the 8th. So we get 4 b to the 8th plus the 4 is reduced to 1 over 1. B to the 6th over b squared is b to the 4th. And then minus 20 over 4 is 5. B to the 4th over b squared is b squared. And there's our final answer there. Now, let's say we're dividing a polynomial by a polynomial. So for instance, we've got 3x squared minus 8x plus 3 all over 3x minus 2. So we put the divisor or the denominator outside and the numerator or the dividend inside. And then we take the leading term inside divided by the leading term outside. 3x squared divided by 3x is x. We place that up there. Then we take the x times 3x minus 2. We get 3x squared minus 2x. And we draw a line. We subtract that quantity from what's up above, change it to addition of the opposite, add up the columns, 0x squared. Negative 8x plus 2x is negative 6x. Bring down the next term and start the process over. Leading term inside divided by leading term outside. Negative 6x divided by 3x is what? Negative 2, so minus 2. Then we take the negative 2 times 3x minus 2, negative 6x plus 4. And then we subtract that from what's up above. Okay, and we change it to addition of the opposite. We get 0x, 3 minus 4, we get negative 1. So we've got x minus 2 plus negative 1 over 3x minus 2. Okay. Any questions about that problem? And then let's recall if we have one that's missing a power. Let's see, let me find one here. Let's say we've got y cubed plus 8 divided by y plus 2. So on the outside, y plus 2. On the inside, we're going to fill in the missing powers of y so that each power is represented. Y cubed, y squared, y to the first power, and the constant term, or y to the 0 power. And then we go back and do the process, leading term inside divided by leading term outside, which is y squared. We take y squared times y plus 2, y cubed plus 2y squared, y cubed plus 2y squared. Subtract that from what's up above, change it to addition of the opposite. Y cubed plus negative y cubed is 0y cubed. 0y squared plus negative 2y squared is negative 2y squared. Bring down the next term, which is just a 0y. Start over, leading term outside divided by, leading term inside divided by leading term outside. Negative 2y squared divided by y is negative 2y, so minus 2y. Negative 2y times y plus 2, negative 2y squared minus 4y. Subtract that from what's up above, change it to addition of the opposite. Negative 2y squared plus 2y squared is 0y squared. 0y plus 4y is 4y. Bring down the next term. Divide the leading term inside by the leading term outside. 4y divided by y is 4. And so we get what? 4 times y plus 2, 4y plus 8, 4y plus 8. Subtract that, change it to addition of the opposite. We get 0. So there's your answer with no remainder. I know that was kind of quick, but I wanted to get through that and get on to chapter 8. So that's what we're going to do. Before we do that, though, anything you want me to go over in more detail? Chapter 5, stuff we've done today? Anybody, anything? All righty, then we will start chapter 8. And let's see, we started with section 8.2. And we talked about functions. The idea that with a function, each input can go to only one output. You can have several inputs going to the same output, just as like you can have several people with the same birthday, but you can't have one input going to several outputs, or like one person with several birthdays. If it's each person has, or each person goes to just one birthday, that's like a function works. Okay, so for instance, I just need to slow down. 1, 2, 3, 4, 5. 1 goes to 4, 2 goes to 4, 3 goes to 5. That represents a function where this is the domain and this is the range. But if you have something like this, 1, 2, 4, 5, 6, 1 goes to 4, 1 goes to 5, and 2 goes to 6. We've got one input going to more than one output. This is not a function. So this is a function. All right, we have function notation. Let's say we have something like this. F of x equals 3x minus 5. And we're asked to find f of 3 and f of negative 1. So basically, we're completing an ordered pair. We're given the input. We're going to find the output. So f of 3 is 3 times 3 minus 5. 9 minus 5 or 4. So f of 3 equals 4 for this function, which is basically the same thing as the ordered pair 3, 4, which would be the point 3, 4 on a graph. F of negative 1 is 3 times negative 1 minus 5, which is negative 3 minus 5 or negative 8. So f of negative 1 equals negative 8, which is the same thing as the ordered pair negative 1, negative 8. Let's see, which would be down here somewhere, right? Okay. Let's see. Let's say you've got something like this. H of x equals x plus 2 over x minus 1. And you're asked to find h of 1. Well, that would be 1 plus 2 over 1 minus 1, which is 3 over 0, which is undefined. So 1 is not in the domain of h, because when you put 1 in, the output is undefined. It's not a real number. Okay. Let's take a look at a couple more of those. Let's say we've got this. F of x equals 5 over x plus 1. The domain would be all real numbers except x could not equal negative 1, because f of negative 1 would be 5 over negative 1 plus 1, 5 over 0, which is undefined. But how would we say x can't equal negative 1 using interval notation? We take everything from negative infinity up to, but not including negative 1, in union with everything after negative 1 up to positive infinity. Okay, any questions about that? Graphing functions. Let's see here. Let's say we want to graph f of x equals negative x plus 2. That's just like graphing y equals negative x plus 2. We could use slope-intercept form. slope is -1 and the y-intercept is 2. So we go to 2 and then go down 1 and over 1 like that. And draw the line. Okay. Or let's say something like this. F of x equals 2. That's like y equals 2. Y equals a constant. That's a horizontal line passing through 2. So that would look like that. And then we get into a bunch of problems where, let me find, let's see. Actually, what I'm going to do, I'm going to close this and then go back and open it up again. And then we'll start over here where we've got certain characteristics given, and then we're supposed to find the function. So here it says, write an equation for a linear function whose graph has the given characteristics. The slope is 5 and the y-intercept is -3. So y equals 5x minus 3, or f of x equals 5x minus 3. I'm using y equals mx plus b, slope-intercept form. Okay. How about one that has a slope of 1/5 and it passes through the point 10, 1. Okay, so y equals mx plus b, 1/5 goes in the place of m. I can take this ordered pair, which consists of an x and a y. The 10 goes in for x and the 1 goes in for y. And I get 1 equals 2 plus b, reducing that down. Subtract 2. B equals -1. So I've got a slope and a y-intercept. Y equals 1/5 x minus 1, but writing it as a function, we get that. What if we've got a line that passes through 2 points? It passes through the point -2, 2, and 2, -8. Well, we could use the slope formula, m equals y sub 2 minus y sub 1 over x sub 2 minus x sub 1. And we'll call this x1, y1, x2, y2, sub 2 that is. Y sub 2 is -8, y sub 1 is 2. X sub 2 is 2, x sub 1 is -2, -8 minus 2 is -10, 2 minus -2 is 2 plus 2 or 4, which reduces down to that. So the slope is -5/2. So that goes in there. Now we can take either one of the ordered pairs. I'll use the first one. That goes in for x and that goes in for y. 2 equals -5/2 times -2 plus b. 2 equals 5 plus b. Subtract 5, b equals -3. So y equals -5/2 x minus 3. F of x equals -5/2 x minus 3. Okay, let's see here. Write an equation with given characteristics. It passes through the point 3, 0, and it's parallel to the graph of g of x equals -2/3 x minus 4. Parallel lines have the same slope. The slope of g is -2/3. So the slope of the function we're trying to find is also -2/3. So y equals mx plus b. That's going to go in there. This is designed for parallel. So y equals -2/3 x plus b. Then we'll put the ordered pair in for x and y. 0 equals -2 plus b. Add 2 to both sides. B equals 2. Y equals -2/3 x plus 2. F of x equals -2/3 x plus 2. So parallel lines have the same slope. What about perpendicular lines? Find the equation of the function passes through the point 1, 2, and it's perpendicular to the graph of, let's see, -x/6 plus 1. That's g of x. Okay. Perpendicular lines have slopes that are negative reciprocals. So the slope for g is -1/6. The slope of the line perpendicular would be +6/1, or just 6. Again, parallel lines have the same slope. Perpendicular lines, the slopes are negative reciprocals. So the slope here is -1/6. The slope over here is +6/1, or just 6. So y equals mx plus b. 6 goes in the place of m. Take the ordered pair that the line goes through. X is 1, y is 2. 2 equals 6 plus b. Subtract 6. -4 equals b. So the slope is 6. The y-intercept is -4. F of x equals 6x minus 4. Finally, a horizontal line that passes through, so horizontal line that passes through the point -8, 12. All right, the equation of a horizontal line is y equals a constant. And the y value here is 12. So y equals 12, or f of x equals 12. And I know I'm cranking through this stuff pretty fast here. Let's see, what do we got here? 8.3 comes up next. 8.3. Let's go back here. And let's say we've got the following graph. And we'll call this the function g, okay? So g of 2, what would we do? We'd find where the input is 2, and we see that the output is 3. So g of 2 equals 3, okay? How about g of -5? Well, g of -5 is +1. Okay. How about find, oh, let's see, how does it read? It says the values of x, okay, the values of x for which g of x equals 2. Okay, so we'll say the values of x for which g of x equals 2. Well, g of x equals 2 is right here and here. So we'd say x equals what? -3, and x equals 0. So those inputs produce an output of 2. Okay. Let's see. How about this? The domain and the range. Well, on the left side, as this is going up, it's also going over. On the right side, as it's going up, it's also going over. So your domain would be all real numbers. The range, however, the y values, the lowest range value is -1, and then it goes on up to infinity. So you'd have -1 to infinity. Any questions on that one? Okay. Let's go on to, let's see here. This is 8.4, which is solving compound inequalities. Okay. The thing you've got to remember with an inequality is, let's say I've got negative 3x less than 12. If you multiply or divide both sides of an inequality by a negative number, you got to change the direction of the inequality sign. Okay. So if you multiply or divide both sides of an inequality by a negative number, you've got to change the direction of the inequality sign. Now, we had union and intersection. We had or and we had and. Or standing for union and standing for intersection. Let's say we've got the following situation. Okay. We've got, let's see here. About this one, 1/2 x less than or equal to 2 and 0.75x greater than or equal to -6. I'm going to solve each separate inequality with the variable on the left side. So the first one, I'm going to multiply both sides by 2 to get x less than or equal to 4. And let's see here. I could do this. I could just divide both sides by 0.75. So I get x greater than or equal to, let's see, 6, or -6, excuse me, -6 divided by 0.75 comes out to be -8. So I've got x is less than or equal to 4 and x is greater than or equal to -8. And means intersection, where they overlap. So I'm going to do a number line, both of these. So x less than or equal to 4 would look like that. X greater than or equal to -8 would look like that. We want and, where do they overlap? They overlap between -8 and 4 inclusive. So your graph of the solution would look like that, from -8 to 4 with brackets. Interval notation would look like that. Okay. Let's say we've got an or situation. Let's see here. X minus 3 less than -4 or -x plus 2 less than 0. Again, we're going to solve each inequality with the variable on the left. So I'll add 3 to both sides, x less than -1, or subtract 2, -x less than -2, divide by -1. So then I change the direction of the symbol. Okay. So I've got x less than -1 or x greater than 2. Well, x less than -1 looks like that. X greater than 2 looks like that. But we want the union. Well, the two don't overlap at all. So the union is going to look like this. We're going to have a single graph, but we're going to have two separate pieces. Did I do that right? No, I didn't do that right. Hang on. Yeah, I got my 2's and my -1's mixed up. Let's see, we've got -1 there and 2 there. Okay. So it's like this. And like that. And then an interval notation, it would look like that. Okay. They don't overlap. That was like I used Hawaii as the example, 2 different islands, still part of the same group, but geographically separated. So there's 2 different intervals that make up the solution. Oh, we also had a double inequality. So something like this, 4 less than or equal to x plus 3 less than or equal to 7, where you've got 3 parts. Whatever you do to solve for x in the middle, you have to do at each end. So you'd get that, the graph of which would look like that. Interval notation would look like that. Okay. 8.5 was solving absolute value equations. No, yes, solving absolute value equations. We didn't do the inequalities. So what you need to do, let's say you've got an absolute value equation. Okay. The first thing you need to do is isolate the absolute value. So in this case, oops, I wouldn't subtract 8, I would divide by 8. So I've got that. Okay. Now, when you've got the absolute value, if it's equal to 0, you're going to just have one equation coming in and solving it. Multiply by 3/2. We get x equals, let's see, that's going to be -15. So then we'll go back and we'll check our work. 8 times 2 times -15 over 3 plus 10 equals 0. That's going to be what? -30 over 3, which would be -10. -10 plus 10 would be 0. Absolute value of 0 is 0. 8 times 0 is 0. 0 equals 0. It checks. If you've got an absolute value, let's see here. Equal to a negative number. So then you're going to have this, or the opposite, equal to the opposite of it. But when you have an absolute value equal to a negative number, recall an absolute value can't be negative. So I can go ahead and solve this thing. X equals 3. And over here, subtract 8, -5x equals -1. X equals 1/5. Sorry, I'm getting so sloppy here. Just feeling like I have to hurry. Let's try those answers and see what happens. If we take x equals 3, we get the absolute value of 8 minus 5 times 3, which is 8 minus 15, which is -7. The absolute value of -7 is 7. 7 doesn't equal -7. X is 1/5. 8 minus 5 times 1/5 equals -7. 5 times 1/5 is 1. 8 minus 1 is 7. The absolute value of 7 is 7. 7 doesn't equal -7, so there's no solution, which you can also write like that. If you got an absolute value equal to a negative number, when you solve it, you get answers that don't work. So there's no solution. They're referred to as extraneous solutions. If you got an absolute value equal to 0, you're going to have one equation which will produce one potential solution. If you have an absolute value set equal to a positive number, then you get, let's take a look at one of those. Let's see here. How about this? Absolute value of 3/4 x plus 4 equals 16. Then you take what's inside equals what's outside, or what's inside equals the opposite of what's outside, and you solve each of those equations. You get two potential solutions. Let's do that. Let's see, subtract 4, 3/4 x equals 12, multiply by 4/3 x equals what, 16? Here, subtract 4, 3/4 x equals -20, multiply by 4/3 x equals -80/3. Okay. Let's check those answers. So let's take this 3/4 x plus 4 equals 16, and let's take x equals 16 and -80/3. X equals 16, -80/3. Okay. If x is 16, we get what? 12 plus 4, 16. So that one checks. -80/3. The 3 is reduced. -80 over 4 is -20. -20 plus 4 is -16. The absolute value of -16 is 16. So here we get two solutions that both work. Okay, finally, 8.9, which is variation. We have direct variation, inverse variation, and joint variation. And you know what? I'm going to pick up from there because I've only got 2 minutes left and I've been cramming it down your throats way too quickly anyway. So we will pick up tomorrow with section 8.9. I will be back at 1:15 with an office hour. Should you have questions, or if there's any particular problems you want me to do, feel free to email me and I'll be sure to include those tomorrow in the Zoom meeting. Otherwise, have a great rest of the day, and I will stop the recording.